Solar cycle 25 is now showing signs of life. What happens on our Sun affects radio propagation around the world. Solar indices are a measure of activity on the Sun. These indices can be used by amateur radio operators to get a sense of how radio signals will propagate globally and when to expect a radio blackout. Sites like Solar Ham give a good insight into the Sun's current activity, presenting easy-to-consume solar weather. But what does it all mean? What's good for radio? And what's not? Our Sun is a huge ball of electrically charged hot gas. This hot gas moves, generating a powerful magnetic field. The Sun's magnetic field goes through a cycle called the solar cycle. Every 11 years or so, the Sun's magnetic field completely flips. This means the Sun's north and south poles switch places. Giant eruptions on the Sun, such as solar flares and coronal mass ejections, also increase during the solar cycle. These eruptions send powerful bursts of energy and material into space. This activity can have effects on Earth. For example, eruptions can cause lights in the sky called aurora, or impact radio communications. Extreme eruptions can even affect electricity grids. In this video, we'll take a quick look at how the Sun affects our hobby of amateur radio. The Earth is blanketed by a protective region of space called the magnetosphere, which is dominated by a powerful magnetic field. It's our planet's shield in space. The measurements from many space missions have been combined to reveal the Earth's magnetosphere is blown out by the solar wind into a teardrop shape. The head of the teardrop extends only about 65,000 kilometres towards the Sun. The tail of the drop stretches away in the direction opposite the Sun, actually reaching beyond the Moon's orbit. This long magneto tail extends more than 600,000 kilometres from Earth. When solar wind is directed towards Earth, this magnetic field acts as a shield. Some of the wind's particles pass through the magnetic field into the ionosphere, a layer of upper atmosphere that begins about 90 kilometres above the Earth's surface. Trapped in the ionosphere, the particles head towards the poles, producing colourful auroral glows. When the solar wind mixes with the ionosphere, it becomes super-ionised, causing destructive rather than productive interference. The turbulence interferes with radio transmissions. In some instances, broadcasts can be picked up hundreds or thousands of kilometres from the transmitter. In others, signals cancel each other out, creating areas where reception is poor. One of the key skills for any DXer is to know how to judge what band conditions may be like.
Damien, I've got you 5 and 151 as well, and I'm in Burnie too. So good to make the contact with you for the first time there, Damien. I'll put it back to you. VK3EJ with the group, VK7JON.
To be able to gain an idea about conditions, three main indices are used: Solar Flux, and the AP and KP indices. A measure known as solar flux is used as the basic indicator of solar activity and to determine the level of radiation being received from the Sun. The higher the solar flux, the better for amateur radio. The solar flux is measured in solar flux units and is the amount of radio noise, or flux, that is emitted at a frequency of 2800 MHz. The solar flux is closely related to the amount of ionisation, and hence the electron concentration in the F2 region. As a result, it gives a very good indication of conditions for long-distance communication.
How's everything down there in Victoria? Coming through quite nicely on 6 today.
The figure for solar flux can vary from as low as 50 or so to as high as 300. Low values indicate the maximum usable frequency will be low, and overall HF communications will not be very good. Conversely, high values generally indicate there is sufficient ionisation to support long-distance communications at higher than normal frequencies. Typically, values in excess of 200 will be measured during the peak of a sunspot cycle, with high values of up to 300 being experienced for shorter periods. There are two indices that are used to determine the level of geomagnetic activity: the A index and the K index. These indices give indications of the severity of the magnetic fluctuations and hence disturbances to the ionosphere. The first of the two indices used to measure geomagnetic activity is the K index. The K index quantifies disturbances in the horizontal component of the Earth's magnetic field, with an integer in the range of 0 to 9, with 1 being calm and 5 being more indicative of a geomagnetic storm. The K index is a quasi-logarithmic number and as such cannot be averaged to give a long-term view of the state of the Earth's magnetic field. So the A index was created, which gives a daily average. During very severe geomagnetic storms, the A index can reach values of up to 200 and very occasionally more. The A index reading varies from one observatory to the next, since magnetic disturbances can't be local. To overcome this, the indices are averaged from Northern Hemisphere monitoring stations and Southern Hemisphere monitoring stations to provide the AP index, or the planetary value. Similarly, the KP index is the planetary average of all the K indices at observatories around the world. So, the lower the KP index, the better for amateur radio. To conclude, generally, the higher the flux, the better the conditions will be for the higher HF frequencies and even 6 metres. However, the levels need to be maintained for some days. In this way, the overall level of the ionisation in the F2 layer will build up. Typically, values of 150 and more will ensure good HF band conditions, although levels of 200 and more will ensure they are at their peak. The level of geomagnetic activity has an adverse effect, lowering the maximum usable frequencies. The higher the level of activity, as reflected in the AP and KP indices, the greater the depression of the maximum usable frequencies. The actual amount of depression will depend not only on the severity of the storm, but also its duration. For best conditions, the solar flux should remain above 150 for a few days, with the K index below 2. When these conditions have been met, check out the bands and expect some good DX to be about.